So if you're building a two-dimensional hydraulic model, it can be really useful to calibrate against 2D hydraulic data, but it's not entirely intuitive exactly how you do that. So in this video, I'm just going to show you a couple ways that I'm using two-dimensional ADCP data to calibrate the velocities in my 2D model. And so what I've got here is I've got these lines of ADCP data that have been collected. They're actually out and backs, so each one of these has two transects. And if I go in here and take a look at it, you can see the path the boat took to make the measurements. And over here, I've got my easting, my northing, I've got depth, and then I've got a velocity. And so the first thing I did is I just turned that into a cross-section. And to do that, this is an approximation because obviously this is a wandering path. But to do that, we just use Pythagoras here, and we say that this distance squared plus this distance squared and the square root is approximately the distance from the origin. And once you turn that into a station, then you can come up with this rough cross section. And since it's an out and back, you get the velocities in both directions. And so the next thing we can do is we can just draw a profile line and get a velocity cross section. And so I've already done that here, but let me just do it again. I'm going to create a profile line, and I'm just going to draw from here to here. And we'll call that demo. And now I've got a profile line there. I've selected my velocity data, and I can come in here to demo, and I can say, hey, give me those velocity data. And I get a velocity curve, and come over here, take that station velocity data, and I have the spreadsheet set up so I can just drop these data here. And you'll see that now I've got my computed velocities across that cross section with the observed from the ADCP data. And actually this model is not doing bad. It's actually catching the velocity dip around the structure. But there is another way to evaluate this. The other thing you can do is you can come up here to the results and you can say, hey, give me a new results map layer. And so what you're going to do is you're going to come in and you're going to ask for velocity results. Now this is weird because we give velocity results by default, so you're not used to going in here and adding velocity results. But what we're going to do is we're actually going to choose a point feature layer. And so now what this is going to do is it's going to pull the interpolated velocity out of the result into each point in a feature layer. And so I have my ADCP locations here. And so I'm going to go and just choose that feature layer, and I'll say OK, and then I'll add the map. And so now you see I have this velocity, but it's not a map. It's a series of points. And if I come over here and look at the attributes, you'll notice that now each of the points on this selected layer has its original data, the easting and the northing, and then we have a depth and the velocity, but then it also has a map value. The map value is the velocity underneath there. And that map value will actually animate with the scroll bar. So as you move the scroll bar, those values will change. My name is Stanford Gibson. I'm the Sediment Transport Specialist on the HEC-RAS team, and this video was funded by the HH&C SET program.